Right, hi everyone. So there was a request for two of the questions in the Easter work to be gone over. So the first one is question 3.3, which is the one that you can see. So what information can you get from the text? So first bit of super important information here is that the replication of the second strand only starts after 2/3 of the first strand has been copied. My first thought was to try and make that a little bit visual because it's maths and you know how it is. So I went for, right, here's my strand. There's my strand of mtDNA, and I don't even know what that is, but I don't care. And let me split it into thirds. Okay, so these thirds have to have happened before replication begins for the second strand. Okay. The next thing it then said was that the piece of mitochondrial DNA is 16,500 base pairs long, and it's replicated at a rate of 50 nucleotides per second. So for every 50 of these nucleotides, it takes 1 second. So I thought, do you know what, I'm going to see how long it takes in total. So I said, right, okay, so it is 16,500 base pairs. If I divide that into chunks of 50, that is 330 seconds. So it's 330 seconds to replicate the whole of that one strand. Then I went back to the information in the question that said about the 2/3 first being replicated. So I thought, okay, so if it's 330 for all of it, it must be 110 for this bit, 110 for this bit, and 110 for this bit. So each third of a strand takes 110 seconds. And we are talking about how long would it take to copy the whole thing. Well, we have 110 seconds, and then another 110 seconds happens. Then we need to copy the whole strand, and we said that the whole strand takes 330. So if we add those all up, we get an answer of 550 seconds, which is C. Okay, so that was the first one. If it still doesn't make sense, then message me on the old Google Classroom. Second question, a bit more complicated. Down here. So just about fits on. So there's a few conversions you've got to do in order to answer this question, and the other thing you need to do is have a look back further in the question. So here at the top it talks about the hydrolysis. Sorry about that. Right, so here at the top it talks about the hydrolysis of 1 cubic decimeter of a 1 molar solution, and then it tells you that it releases that amount of energy. Okay. If you have a look further down the question, it says that the student added 0.05 centimetres cubed. And so when we're talking up here about this much energy, 30,500 joules of energy, that's from 1 cubic decimeter. It's important to know that 1 cubic decimeter is the same as 1,000 centimetres cubed. So student only used 0.05 centimetres cubed, not 1,000. So 1,000 divided by 0.05 gives you a number which I wrote down somewhere. Oh, 20,000. I know I should just know that, obviously. That's just, maths in your head, right? So there are 20,000 times the volume that the student used in this number up here. Okay, so the first thing I did was go, well, okay, of this 30,500 joules, the student was looking at a 20th of that, so 20,000th of that. So if you divide it by 20,000, you're saying, okay, we're not looking at a whole 1,000 cubic centimetres here, we're looking at 0.05, which is 1/20,000th of that. So this volume, this number of joules here, divided by 20,000, gives you 1.525 joules. So we know that there's 1.525 joules in 0.05 centimetres cubed. Okay, so that's useful to know. The next thing was, what else can we pick out from here? They added, this is the volume, which we've just dealt with, but they said it was the solution that was on slide D. And that's where you need to refer back to your, further back in the question. Now, I am telling you now, because I looked it up, that slide D has a concentration of 8 times 10 to the minus 6 moles per cubic decimeter, okay? Here, it's talking about 1 mole per cubic decimeter. So this is a lot less than 1 mole per cubic decimeter. So we need to, again, have a look at how much less is this. So if we do 1 per cubic decimeter divided by 8 times 10 to the minus 6, you get a value of 125,000, okay, which means that the concentration the student used, 8 times 10 to the minus 6 is a 125,000th of this concentration here. So again, we take the value that we had here. We said there were 1.525 joules in 0.05 centimetres cubed of the 1 molar solution. We're using a much lower concentration. Okay, so we then need to divide this number. We need to divide it by 125,000 because our concentration we used was 125,000th of this concentration here. So we divide by 125,000 and we get a value of 1.22 times 10 to the minus 5. Okay, so that is the number of joules of energy that is released when you use 0.05 centimetres cubed of a 8 times 10 to the minus 6 moles per cubic decimeter solution. Okay, but then just to add to the stuff you need to do for 3 marks, up here it talks about 60% of the energy released is heat. The rest is muscle contraction. And what is the rest? 40%. So of all of this energy, only 40% is used for muscle contraction. And the question is asking you how much energy is needed for muscle contraction. So this value times by 0.4, which is essentially 40%, gives you an answer of 4.88 times 10 to the minus 6. Okay, so this is how you carry out that calculation for 3 marks. Fantastic. If you followed that through and thought, brilliant, I can do that in an exam straight up, fine. If you are still struggling to get your head around it, don't worry about it. It's the kind of question that in an exam you skip and move on and only come back to if you've got time. Okay?